Now we will try to prove a famous theorem in quantum mechanics, which is a very simple one. We know about observables in quantum mechanics are represented by operators. So, in most of the quantum mechanical problem which deals with the physical measurable quantities, we have Hermitian operators. So, we have a theorem about the eigenvalues of Hermitian operator, which states that I'll state the theorem first. The theorem states the eigenvalues of a Hermitian operator, we say A, operator A, are real. They are real. The eigenvalues of a Hermitian operator would be real. The eigenkets corresponding to different eigenvalues. We have two, for example, we have two eigenvalues, and corresponding to the eigenvalues, that there will be two eigenkets, and there will be corresponding to these eigenvalues, there will be eigenkets, and they would be orthonormal. Eigenkets are orthonormal. This is the theorem we are about to prove. For that, we consider the operator A, which acts on the eigenket A prime, give you A prime, A prime. We call it as equation 1. Here, this is A is an Hermitian operator. A prime are the eigenvalues corresponding to the operator A for the eigenket A prime. So, we know A is Hermitian, A is Hermitian operator. So, I can write the equation in a different form, such as you take another bra which we have an operator A, because if you take the dual of this becomes A dagger, but it is Hermitian, so it is A only. So I'll have A double prime star. I don't know whether the eigenvalues are real or not right now, so I'll write it as A double prime. This is equation 2. Now you multiply equation 1, you multiply equation 1 by bra A prime from left. You multiply from left, and you multiply equation 2 into A prime from right. So I'll get a new two equations which stays A double prime A prime is equal to A double prime A prime A prime. Here this is scalar quantity, you can take it outside. So this is equal to A prime A double, sorry, A double prime A prime. This is, I'll say, equation 3. Similarly, here you have A double prime A, will have A prime if you multiply by 2. So one equation 1 implies this, equation 2 implies this. Prime will give you again A double prime star A double prime A prime. Am I right? So this is equation 4. You subtract equation 2 and 3, sorry, 3 and 4, you get so equation 3 is this, and equation 4 this is on the left hand side is same. On the right hand side we have A prime minus, I'm sorry, A prime minus A double prime star multiplied by A double prime A prime scalar product, which gives you 0. Okay, this A prime and A double prime are scalar quantities, and this is again a scalar. Okay, so in order to get this product to be 0, either of these has to be 0. Now you choose the case A double prime equal to A prime. A double prime equal to A prime. Case 1. They are the same, which means you will get A prime minus A double prime star A prime equal to 0. We know this is equal to unity, so this quantity A prime minus A double prime is A prime. So I have to write A prime. I have to write, sorry about that. I have to write this is to be A prime. A prime star has to be 0 because this is 1, so this has to be 0, which means A prime equal to A prime star implies A prime is a real quantity. So we have proved the first part of the theorem. Now you take another case, case 2, A prime not equal to A double prime. And we know that these are real, already proved that, so I can write A prime minus A double prime star is into A double prime A prime, sorry, A prime equal to 0. Uh, sorry, correct, A double prime A prime equal to 0. And I said they are not equal. In that case, this quantity cannot be same, right? This is A prime minus A double prime. They are not equal. A double prime A prime equal to 0. This is non-zero because of condition for case 2. The condition for uh, case 2, condition for case 2, because this is the condition we have chosen for case 2, A prime not equal to A double prime, so this cannot be 0. The first part cannot be 0, implies, I'll write it here, A double prime inner product of A double prime A prime has to be 0, which means they are orthonormal, because we have already chosen this A prime to be, they are all normalized, this is a basis, so they are orthonormal here. A prime A double prime A prime equal to 0. So this is how we prove